So you can think of Embedder as like it's an AI coding agent, but it's one that we've given hands to that allows it to interact with the real world and verify that its work actually works on the systems that it's designed to program.
On this episode of Embedded Insiders, Ethan Gibbs, CEO of Embedder, joins us to discuss his company's AI firmware engineering platform. Built for embedded development, the Embedder hardware-aware coding agent is designed to reduce the time it takes engineers to read datasheets and write code. It poses the question, what happens when AI actually understands the hardware? Next, Rich and Steve Hanna, a distinguished engineer at Infineon Technologies, discuss the increasing capabilities and access to AI tools and how they can potentially help cybercriminals by providing more sophisticated tools that make their job easier. How is AI reshaping the threat landscape, and what does this mean for the future of cybersecurity? Hello, everyone, and welcome back to the Embedded Insiders podcast. I am Assistant Managing Editor Tiara Oliver, joined as always with our Editor-in-Chief, Ken Briota.
Hi, Tiara, and how are you today?
I'm good. Trying to stay cool in the Arizona heat.
Yeah, well, we're getting our own taste of the heat over here on the east coast of the U.S. Not nearly as bad as some other folks are getting it, though, so I probably shouldn't complain too much. Have you been following World Cup at all?
Yes and no. I've only seen clips, and
I've only been casually following it myself, paying a little attention, catching a game on TV where I can. But it has been fun. It's funny because I've been talking to some folks who are really into it, and everybody's really enjoying this tournament. It's been a little bit wild, but I'm already looking forward to the next one, which is going to be hosted by Spain and Portugal, and I think Morocco. Maybe I'm wrong there. And that sounds awesome. First of all, geographically, all of the stadiums will be a lot closer together than they are for this tournament. And I'm like, oh, maybe I should go watch some football in Spain. That sounds fun.
Yeah. I mean, honestly, the main things I've been following about the World Cup are everyone coming to the US and trying food and the whole ranch debacle.
Oh my God, it's been so funny. And the Scottish invasion of all the Scots coming. You heard about the plane that they were on where they ran out of alcohol on the plane.
Yeah. Oh my goodness.
Welcome to International Football Talk here on Embedded Insiders with Tiara and Ken.
We all knew this is what you wanted to hear instead. So
that's right. We're going to talk about the weather and sports, and if you're very lucky, we may talk a little bit about, hey, how's it going? Not bad, you?
With a little dash of AI, as usual.
As always. I know that you've got a really cool series of interviews on this episode. Can you give us a little preview before folks get into it?
Yeah. One of our interviews that we actually spoke about on the podcast back in March after Embedded World, when we were recapping everything and kind of just talking about some of the favorite things that we saw. And one of them that I mentioned was Embedder and how great my meeting went, kind of just speaking in general to younger engineers they have a really cool solution that I spoke to them about at Embedded World and finally got them on the podcast. And I spoke with their CEO, Ethan Gibbs, and yeah, just their AI firmware engineering platform. And it's called Embedder. It's also the name of the company, but it's a hardware-aware coding agent, designed to, I guess, cut the time it takes for engineers, who have to spend time reading data sheets and writing code. And I feel like we talk so much about, AI, the negatives and the positives, but I thought this was a pretty positive solution. And I think
Yeah,
you thought the same. Yeah.
yeah, absolutely. I mean, it was nominated for the Embedded Award at Embedded World this past March in Nuremberg. And the thing I found most interesting about it, and was really impressed by, was it was a really good example of what I think is a really good trend of eschewing the large data lake and the large model for specifically trained tools. So in this case, Embedder is trained on the specific documentation, data sheets, handbooks, everything for whatever your platform is that you're building on, your hardware, your software, whatever. And then you use that model that is only trained on the thing that you're working on to help assist you in design and code. And it because it's so specifically trained, it's purpose built. You avoid a huge percentage of errors. Not that you don't still have to double check, obviously. You drastically decrease the chance of hallucination. You'll just allow yourself to work more efficiently and more accurately, speeds time to market, and it's really smart design. And that's what I'm seeing now at shows that I've been going to ever since Embedded World, where the AI tools, especially edge AI tools, but not just there, are being used sort of in a way that I call practical AI, where instead of being worried about it being able to do everything poorly, they're using AI tools to do one specific thing or set of things really, really well. And that to me is smart, strategic, good engineering with AI. So Embedder as a startup was really ahead of the curve here, and even one of the leaders. So it's a startup where I'm definitely going to be watching, and I'm really excited to hear your interview, because I think that they're a really smart team, and it'll be really interesting to listen to what Mr. Gibbs has to say.
Yeah. And I think it also goes to the whole point of also AI being like the assistant, or the assistant engineer, and not replacing the engineer. So I always like those solutions, of course.
Well, yeah, I mean, they're not calling it an agent. They're not referring to it as agentic AI, which I don't think it is, but that to me is the ideal purpose of that sort of agent model, that assistant model. AI is, in my opinion, really great at taking tasks that the engineer could do, but takes a lot of time and is a lot of menial sort of labor, and makes those tasks simpler, or automates them, and allows the engineer to focus on the tasks that the AI shouldn't be doing and will be bad at, like design, like integration, and things like that, so that the engineer can really focus on those important work that needs the engineer's expertise. And as you say, the AI becomes their tool, their assistant. And that's what, for me, is the best case scenario with agentic AI and these AI tools that are used in creation and design. Obviously, it's a little different for AI tools like at the edge that are being used in execution and application of a device. Although I think they should also be kept to that assistant agent role, where they are easing work that will be time consuming and for lack of a better word, busy work for a human whose time could be better spent on something else.
Exactly. Yeah.
Yeah.
I mean, you said everything. Very well said. And I even pulled out some of my notes from Embedded World that I wrote when I was meeting with them. And just going back to the point of like two main things that Ethan had mentioned, which was, this is for building trust. It's not supposed to scare people. They really wanted to introduce AI in a way that's not, I guess, stressful and overwhelming as it is, because it's everywhere.
Yeah.
And they also wanted to draw out the point that AI can be valuable. It's being used in a lot of random ways right now, but it's important to focus on the good things as well.
Absolutely true. And yeah, we're still, in my opinion, still in early days. We're a long way from mature in the AI
Mhm.
world. But to my mind, in the engineering sphere, this move toward purpose-built, small model, tailored, specific, practical AI is really positive. I think
Yeah.
that that's going to make the work of engineering that can be, can have tedious elements, less tedious and more exciting for engineers, which is needed because we're short of engineers everywhere.
Mhm.
We're always hearing about this sort of uh, desert of talent, and we need more and more engineers. And if those engineers know that they're not going to have to spend, four times the time they're designing on reading the documentation, then I think that that's a very exciting prospect.
Exactly.
Yeah, well, I was just going to say though, before we move
Yeah.
to the interview, uh, uh, not only is the embedder, I want to call it embedder available now if folks want to check it out after they've heard the interview. It's also supporting like ecosystems from ST, Expressive, Nordic, NXP, Infineon. Like they've been really strict, really smart about how they've built their integration ecosystem out. So worth checking out as a product too, as well as hearing the thinking in the interview that's coming up next.
Yep. Stay tuned, everyone.
Now, here's Ethan Gibbs of Embedder.
So Ethan, welcome to the Embedded Insiders podcast. I know we spoke a bit about Embedder, your company at Embedded World. But yeah, for those listeners who may not be familiar with what you do, can you explain what it is that Embedder does and some of the core ideas behind your AI firmware engineering platform?
Yeah, glad to be here. Thanks for the invitation. Um, I guess just a quick background on what Embedder does. Like you said, it's an AI platform for firmware engineering, but some of the core ideas that we have in Embedder are about information in general. Um, we believe that embedded development is actually not a foundational model problem, and that it's actually more related to the uh, the context that you provide, like the LLM, when you're developing firmware. And this context can come in two different forms. One of them being information in terms of like documentation, like your data sheets, your schematics, reference manuals, or basically anything that describes the hardware you're working with and how to program it. And then also information in terms of like what's actually going on in the real world. Like when you actually write this code based on this documentation and you know, you want to test it, uh, how do you actually confirm that what you made works on the actual microcontroller that you're working with? And how do you pull that data in from those like real world sources and use that to inform like the LLM during the generation process? So what Embedder does basically is it converts documentation into code, and then it uses real world data sources to plug them kind of into like this iteration loop that allows the AI to autonomously get feedback on how the code that it wrote is performing in like the real world. Um, so you can think of Embedder as like it's an AI coding agent, but it's one that we've given hands to that allows it to interact with the real world and verify that its work actually works on the systems that it's designed to program.
Awesome. Are there any, I guess, big big trends or challenges in the industry that you set out to solve with this solution, like the biggest trends that you're seeing in firmware development that are creating a demand for a solution like Embedder?
Yeah, so a lot of our customers are, well, there's a couple trends. So one of them being that the amount of actual qualified firmware engineers like on the market is dwindling. So there's a lot of entry level people going into electrical engineering and wanting to get experience building, electronics, things with microcontrollers. But the amount of actual like engineers with like 3 to 5 years of experience is very small, because a lot of people, there's been structural changes that have pushed people into doing software engineering. But that's because of the market, the amount of jobs. They might find it more interesting. It might be more accessible. There's not as steep of a learning curve. So like the amount of people that actually have accumulated experience in the field is very low. So most companies will actually only have they might have a team of like 100 engineers, but they might only have 2 doing firmware, and their job is mostly just maintaining the code that they already wrote a couple of years ago. So one is unfilled jobs and needing a way to augment existing engineers to make them more productive to keep up with demands, or basically replace these job openings or augment software engineers and give them the ability to do firmware engineering work. And another trend we're seeing is also like increasing regulations requiring people to go back to old code and modernize it, harden it for these security standards, or generational upgrades between different microcontrollers. If you're working on a last gen platform and a new one came out and the tech debt is catching up to you and you finally just need to like go back to the firmware and rewrite it and port to this new platform, we have a lot of customers doing platform migrations. So this is mostly all just kind of like things are kind of converging to force people into having to get back into like writing really great low level code. And there's not really enough people to do it. So they're looking towards solutions like ours to help them accelerate that process and modernize everything very, very quickly without having to increase their headcount. So it's kind of like everything's all pressuring, like compliance, things getting old, engineers kind of drying up. We need a solution that helps people get the same amount of work done in like half the time.
Awesome. And you describe Embedder as the world's first hardware-aware coding agent. How would you describe that in practice? How is it different from those traditional AI coding assistants that we've seen?
Yeah, I think I touched on this like a little bit briefly, but the reason why we call it hardware aware is it's hardware aware in the sense of like it understands your hardware as described by the electrical engineer who wrote the datasheet and did the schematic. So our AI has understanding of, as to the same extent that an engineer would if they looked at the diagrams, they looked at the data sheets. We use computer vision to read complex technical information. And then hardware awareness in the sense of it can read logs and connect to all your test bench equipment like serial, RTT. It can control debugging sessions through GDB. It can capture logic analyzers, oscilloscopes. It can measure power draw. So I think that's kind of just getting back to like it understands it fundamentally better before you even write your first line of code. And after you write the code and you're onto like this verification and testing phase, Embedder is able to literally be aware of what's going on in your hardware by connecting to it and reading logs and signals from it.
Awesome. And I think you already answered one of my questions about how Embedder interacts with hardware during development. Um, do you have any examples of how it improves performance or efficiency?
I do, yeah. I can talk about one like at a high level. We've had some customers building applications that are power sensitive, and they need to do basically how do we decrease the idle power consumption of this firmware or running on this like device, this IoT device that we're building while it's in the field. And typically doing these like micro optimizations on power consumption or memory footprint are very time consuming. They require the engineer to sit down and iterate and try different things and come up with different experiments. And something we've been able to do with Embedder is basically when an engineer writes a code, we consider that like the initial candidate, and they push this code to GitHub through a pull request. And automatically, Embedder is able to attach to that pull request and run the firmware with hardware in the loop and check how much power is it consuming or how much memory is it consuming. Do we need to make any optimizations? And then from there, it's able to generate like 10 different candidates of the same functionally correct firmware, but with different like power optimization strategies. It can run them in your CI/CD pipeline and actually check, and get a report back. What is the like the performance summary from that particular firmware running on a real hardware in the loop test, and can basically do that all automatically. You submit code to GitHub, and it automatically provides you like the most efficient like permutation of that code that has the same functional like equivalence there. So that's one example. We've had people do like autonomous like optimizations like as a part of their CI/CD pipeline, which is very cool. So they don't even really have to think about performance. They just have to think about, can I get this code to work? And then it can automatically kind of approach this like very, very optimal solution.
Awesome. And scaling back a little bit, I kind of just wanted to pick your brain a little bit. We're seeing AI a lot used in software development, but less in hardware near environments. Why do you believe that AI has held back in embedded systems until now?
It's a good question. I think there's like structural reasons. Like obviously AI kind of depends on the quality of the information you can give it for it to like predict a plausible output. And I think historically the way that the internet was constructed, it was software built by software engineers who publicly documented the software they built, and they made it free and open to everyone. And general purpose AI, maybe not so much now as it used to be when it first came out, it's trained on a corpus of like the entire internet. And you'll find that most of that is actually high level software code. Whereas with embedded, most of it is actually very, very low level firmware code that is the majority of it offline. So for example, you wouldn't want your proprietary firmware controlling very, very important national infrastructure publicly available on some open source repository for people to be able to exploit and destroy like the telecom infrastructure of the country or something ridiculous like that. And it's also just like an older legacy industry, so they're not really like, they're more concerned about IP security, keeping everything offline and air gapped. So there's not really much to work with in terms of like training data. So I think the reason why it's stalled a bit is because one, firmware is at a bit of a disadvantage compared to like open source software in terms of like how good can we get AI at pattern matching, because there's not very much to pattern match against to write good code for various applications. So the approach is basically, how do we get to a point where AI systems are good enough to understand what good firmware looks like, and then we can find a way to collect and orchestrate information to fill in the gaps. So that's kind of like what we're saying is like, we don't think that there will ever be enough examples because of the nature of code being proprietary. It's just IP sensitive. But if we do get access to the IP that describes what the code should contain, then there are ways to build a system that can use that to write code just as good as if it had trained on it. So it's kind of this gap between like wanting to train on things, but you're not allowed to because it's IP sensitive. So then how do we get this IP sensitive information into the loop that allows us to actually write stuff that works on our even proprietary hardware?
And looking ahead, how do you foresee the role of AI evolving in firmware and embedded systems, over the next few years?
I personally believe that everything is going to be automated from a high level business logic specification. And I don't see any reason why that wouldn't happen. Where we're going to have like a handful of high level senior engineers who have very deep system design type understanding of like what they want to build, what the architecture will look like, the trade-offs, and be able to understand what the AI is doing at all times. Kind of like a staff engineer managing a team of like junior ICs. And the ability to plan, delegate work, review code, approve it, and then ultimately like sign off on like the deliverable is going to be the role of pretty much every firmware and software engineer in the future, where we go from being individual contributors to supervisors and orchestrators of multiple different agents. And I think it will happen in software sooner than it will in embedded adjacent fields. But I think it will have the largest impact in embedded software because it's a traditionally very error-prone, slow manual process, and hardware is becoming increasingly important. I just imagine a future where new physical technology gets shipped at the speed of software, and you have a cool new, a new car or a new mode of transportation or a new phone or a new camera every month instead of years. Like the R&D cycle compresses, and we're just going to have so much capacity for people to innovate because the cost of experimenting is going to approach not zero, but probably some fixed cost that some businesses will be able to like play around with. I think it's not like a 2-year commitment to designing and shipping a product. It's like somebody can prototype something they think might be great for the business in a month or in their own free time with tools like this, and they don't need a full team of engineers to research it. And I think that's my view of the future, and I think that's going to be very exciting.
Yeah, no, that's a great perspective. I believe those are all the questions I have for you today, Ethan. But as always, I like to ask if there's anything that I might have missed or anything else you'd like to add.
No, I think that's all, other than if anybody listening is interested in what we're doing, you can go to our website at embedder.com and you can learn a little bit more.
Now, here's Steve Hanna of Infineon Technologies.
Good afternoon. Welcome to the Embedded Executive Podcast. I'm Rich Nass with Embedded Computing Design. This week our guest is an old friend of mine, Steve Hanna, a distinguished engineer from Infineon. How are you today, Steve?
I'm doing great, Rich. Thanks
That's
for having
good.
me.
My pleasure. Well, I had you because you scared the you-know-what out of me the other day over lunch. So I said, why don't we just scare the whole world with this topic? And the topic is, let me get this right, the growing cybersecurity risk of artificial intelligence and what can be done about it. So you and I had this discussion over lunch about how this is a really scary time, and we need to stay ahead of the bad guys when it comes to AI, but it's way more involved than that. So I'd love for you just to go through it the way you went through it for me over lunch, and let's just talk through this again.
Absolutely. So we've known for some time that these large language models, the same ones that we use in ChatGPT and Copilot, that they have growing capabilities in coding and in analyzing code, which is a wonderful thing. It allows software developers to be so much more productive. But there's a bit of a shadow side to that, in that when they analyze code, or a code base, as a group of software is considered called, they can find vulnerabilities in that code. And they can even chain together those vulnerabilities into what are called exploits, which is basically the ability to, say, achieve some goal with respect to the software, such as running an arbitrary command or getting admin or super user privilege on a particular system. So these cybersecurity offense capabilities of the large language models have been increasing at an exponential rate. And the latest data shows that today's frontier models, the real cutting edge ones, Claude Mythos and GPT 5.5, can, if they're properly configured with the right tools and harnesses, achieve cybersecurity offense capabilities equivalent to those of skilled cybersecurity experts. And that has some real serious implications for the security of our software and the things that we depend upon.
Well, let me interrupt you here, Steve.
Yeah.
99.9% of what you're talking about is using this technology for good. And that's why it is being pushed to the extent that it is, right?
Yes. Yes,
Okay,
that's
I just
right.
want to be clear on that. Okay.
The folks who are building these models are not building them to be used for malicious purposes. In fact, they've put on handcuffs on the models that most people have access to make sure that they're not used to find those vulnerabilities and build those chains of vulnerabilities into exploits. The thing is that the bad guys can get their hands on these models, or the attackers, shall we say, can get their hands on these models without the handcuffs. One of the ways that that happens is that researchers have shown that open source, or as they're called, open weight large language models, can achieve comparable results. So these are things that well, that they can't handcuff because they're effectively open to anyone. And we can assume that the militaries of all of our major nations that have a cyber arm to the military, which is effectively all of them these days, have access to similar capabilities. And it's not just the military, but we have to assume that the criminal rings and organized crime will get their hands on them as well. So let's look at the bright side, though, as you pointed out. Not only are these models useful in vibe coding, as they call it, using these models to write lots of code, but the cybersecurity defenders can use the models to find vulnerabilities in their own code and then to create patches for those vulnerabilities and integrate those patches. So this is what's been happening for the last couple of months. People have surely heard of Project Glasswing or of Claude Mythos itself. Anthropic, who makes Claude, has restricted access to Claude Mythos for a few months to what they view as critically sensitive companies. Only those companies get access to Claude Mythos. They're part of this project Glasswing. And they've been using Claude Mythos to find vulnerabilities in their own code. So Microsoft, Google, Amazon, and Cisco and others have been looking for vulnerabilities, finding vulnerabilities, patching those vulnerabilities at a frenetic pace for the last few months to make sure that when these frontier models get out there and the attackers get their hands on them, that already many of the vulnerabilities, at least the most serious ones, will have been found and fixed. That's certainly the hope. And some open source groups, for example, Red Hat Linux and Linux Foundation are also able to get their hands on it. Not everybody. I mean, the number of software developers and companies that make software or software as a service is much bigger than they can accommodate in this Project Glasswing. But they are gradually opening the program to more companies that make software, and those companies are using the tools to find their own vulnerabilities and get them patched, we hope, before the attackers can find the vulnerabilities. But it points out the importance of installing those updates as soon as they become available, because if Microsoft releases a set of patches, for example, for Windows, within certainly a few days, those patches will be reverse engineered and the attackers will figure out how to exploit them. So you have to get your patches installed right quick now. And there will be and are being more and more and more patches coming out because of this superpowered and supercharged capability for finding vulnerabilities.
So let's go back to the idea of the handcuffs. What exactly does that mean? And are we trusting the people who are putting them in place?
Well, I'm happy to say that both Anthropic and OpenAI have cybersecurity teams, and it was they who pointed out this tremendous increase in the capability of the models, nonlinear increase in the capabilities of the models. So they're the ones who designed the handcuffs based on their experience using the models. And the handcuffs might, for example, restrict the set of requests that you could make to Anthropic, to Claude, if you're with Anthropic, or GPT 5.5. And if you make an illegal or unauthorized request, one that's restricted by those handcuffs, for example, here's a bunch of source code, please find those vulnerabilities for me, and you're not part of Project Glasswing, then they're going to deny your request. It is possible for the AI to sometimes be tricked into avoiding those constraints. We've seen that over and over again with clever prompt engineering. You can sometimes get the AI to do things that it was programmed not to do. So I wouldn't regard this as being a bulletproof protection against cyber attackers using their models, these models, commercially available models, for finding vulnerabilities. I do expect that we will see, especially with companies who are not part of Project Glasswing and therefore don't get that early access, that we'll see an arms race, so to speak, between the good guys and the bad guys, trying to find the vulnerabilities before they can be exploited.
But that was my point exactly, that we've agreed that it's impossible to write code that does not have any vulnerabilities. Isn't it just a matter of time before they get exploited?
Well, that's always been the case, Rich. What's changed here, it's always been the case, as you point out, that the software has vulnerabilities and that they can be exploited, and the bad guys look for them, the good guys do as well. What's changed is the pace. Just crank it all up by a factor of 10 or more.
On both sides?
On both sides, yes. Both sides, so long as they have the ability to buy the tokens and use the AIs, they have the ability to increase the rate at which they can find those vulnerabilities, because you don't have to have a cybersecurity expert any longer in order to find them. And yes, there is some so-called AI slop or hallucination, or just error on the part of the AI, where some of its vulnerabilities will turn out to be not very serious, or maybe not vulnerabilities at all. But the AI can be used, you can set up one AI against another to filter out that slop. So yeah, both sides are really cranking now, cooking with gas, as they say.
So is the best method here just keep your fingers crossed?
No, I would say for anyone who develops software, you need to do everything you can to start using AI and learning how to use AI to find vulnerabilities in your software. And you need to talk with your suppliers, because most of us use tools and libraries to make our software work, whether that's a security library like OpenSSL or a graphics library, whatever, to make sure that they are also cranking up, using this turbo power, so to speak, to crank up their ability to find vulnerabilities and get them patched, and then to make sure that those patched version of the libraries gets included in and built into your software offerings right away. But there is an action for consumers here as well. It's not all about the companies that make the software products or the hardware products, because of course hardware these days has a significant software component. There's also an element of consumer responsibility as well. That, as I mentioned earlier, the consumers have to install those patches ASAP. And if the consumer or the customer, if it's a commercial or industrial customer or a government customer, if they don't have the ability to quickly install those patches, they need to change their assessment of the risk that constitutes to their organization or enterprise. They have to realize that the risk is considerably greater now. There are, at least there will be for the next few years, much more rapid, many more vulnerabilities coming much more rapidly. And if you can't patch things, you need to take them offline so that they can't be remotely exploited. Put them behind an air gap if you can, or at least behind a careful DMZ set of firewalls to protect them from external attack. That may not be completely effective, but you really need to be upping your game from a defensive standpoint.
Yeah, that's what I was thinking. The best way to defend yourself is just unplug, go back to paper and pencil, and then you won't get exploited.
You know, the UK's government's cybersecurity agency actually recommended last fall to their businesses that they have a backup plan where they could go back to paper and pencil, because they have several of their major supermarket chains that got attacked, and Jaguar Land Rover also had its factories down for more than a month because of cybersecurity attacks. So they said, you know, you have to have on hand what you need to be able to do your job and to keep your enterprise up and running if, you know, everything goes sideways and you do have to fall back to a manual process. Well, when I talk with customers, I tell them the same thing. Of course, for most of us, that's pretty hard to imagine, but, you know, having some sort of a backup plan if your systems or the services upon which you depend are unavailable, you know, it's a good fallback, so you're not out of luck. If that
Imagine that, having to turn the lights on and off by hand and having to open the blinds by hand. Oh my God, I don't know if I could do that again.
Well, Rich, you're in luck in a way, because when we built the Matter standard for smart home, we built it based on a zero trust architecture. The idea that we knew that some of the things in your house were going to get infected, and that we wanted to minimize the impact if that did happen. So, for example, the light bulbs in your house only get the privileges that they need, which is very little. So if they do become compromised, then the harm that they can cause is very low within your house. Now, that being said, you know, that's smart home. I guess the worst case scenario is you have to unplug things to turn them on and plug them to turn them back on, to turn them off and on. But we need to look at other more serious things as well, such as industrial equipment, critical infrastructure, and make sure that that's adequately protected. I think that's one of the reasons that the Trump administration, in their new executive order on AI, required that or set up a structure by which critical infrastructure providers could be informed rapidly of cybersecurity issues as they emerge, and required review of new AI models to see what their cybersecurity implications are.
Very, very interesting, Steve. And I think this is just the beginning of the series that we're going to be doing on this topic as we go along. I do appreciate all the work that you've put in to make this work and for helping educate me.
Yes, I'm happy to do so. And I'm hopeful. You know, I am an optimist. I know it's going to be a stormy few years, but I am hopeful that in another 5 years, all of the software is going to be just so much more robust because of the hailstorm of vulnerabilities that will have been coming at it, and the many patches that will have been put in place. So in the end, we may well come out in a better place from a cybersecurity perspective.
Very good. That was Steve Hanna. He is a distinguished engineer with Infineon, and I am Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.